Hello students, in continuation to our previous module, hydrostatic pressure, here we are going to discuss atmospheric pressure and Pascal's law. Here we are going to discuss atmospheric pressure. What is atmospheric pressure? Atmospheric pressure is the pressure exerted by the Earth's atmosphere. So, how can you calculate the pressure exerted by the atmosphere? To measure the atmospheric pressure experimentally, Torricelli invented a mercury barometer in 1643. The atmospheric pressure at any point is numerically equal to the weight of a column of air of unit cross-sectional area extending from that point to the top of the atmosphere. You know that the atmosphere is extended from this surface to the height of the atmosphere. If we want to find out the atmospheric pressure at this point, you have to imagine a unit area here and an air column above this. How much is the weight exerted by this air column on this area? That is the force exerted. That is force exerted on that area. That is the pressure. Here the force is exerting by the atmosphere. So we can say that this is the atmospheric pressure. So we can define the atmospheric pressure at any point is numerically equal to the weight of a column of air of unit cross-sectional area extending from that point to the top of the atmosphere. How can you measure the atmospheric pressure? To measure the atmospheric pressure experimentally, Torricelli invented a mercury barometer in 1643. It consists of a long tube filled with the mercury and then inverted in a trough of mercury to stand vertically as shown in this figure. The space above the mercury, it is vacuum and this is called Torricelli's vacuum. The mercury sinks down and up to a height of 76 centimeters. Here, the atmospheric pressure supports the height of the mercury column. You know that the pressure at the same depth is same. That means the pressure exerted by the atmosphere is equal to the pressure exerted by 76 centimeter of mercury. Mercury, you know that density is more, so the height becomes less. So, in this way, we can measure the atmospheric pressure. So, the atmospheric pressure is the pressure exerted by a mercury column of height 76 centimeter. We used the formula for hydrostatic pressure to determine the magnitude of atmospheric pressure. From this experiment, he has seen that the atmospheric pressure is equal to the pressure exerted by mercury column of height 76 centimeter. So, he used the formula P is equal to H rho G. H he took 76 centimeter. Rho is equal to 13.6 into 10 to the power 3, that is the density of mercury. G 9.8 meter per second square, acceleration due to gravity. After putting these all values, we got 1.01 into 10 to the power 5 Newton per meter square or 1.01 into 10 to the power 5 Pascal. This is 1 atmosphere. 1 atmosphere is equal to 1.01 into 10 to the power 5 Pascal. Next, we are going to see what is Pascal's law. Pascal's law states that when pressure is applied at any part of an enclosed liquid, it is transmitted undiminished to every point of the liquid as well as to the walls of the container. This law is also known as law of transmission of liquid pressure. See here, when you push this piston inwards, then what happened? The force applied here, it is F1 and the area is A1. So pressure here, it is F1 by A1. In order to prevent the motion of all the other pistons, additional forces F2, F3, F4 have to be applied at the points B, C, D respectively. It is found that the pressure applied at this point is equal to the pressure at the points B, C, D. This is the demonstration of Pascal's law. See here, when you apply the force F1 here, so the area is more, so pressure is F1 by A1. Here the area is less, the force is less, F4. That is F4 by A4, but the pressure becomes same only. Next, what are the applications of Pascal's law? Pascal's law have so many applications in our daily life. One is hydraulic lift. See here, this is the diagram of a hydraulic lift. Hydraulic lift is used to lift heavy loads. Here two cylinders are here. It is having different area of cross sections. Here the area of the cylinder is A1 and here the area is A2. Heavy object is placed over the large area of cross section. F1 is the force applied here, then the pressure here is F1 upon A1. You know that according to Pascal's law, the pressure will be transmitted equally. That means here area is more, force will be adjusted itself to equalize the pressure. So P is equal to F2 by A2. Due to this large force, the object is lifted up. So this is the principle we are using in hydraulic lift. Now the explanation is given here. It is a simple device based on Pascal's law and used to lift heavy loads by applying a small force. The basic arrangement is shown in figure. Let a force F1 be applied to the smaller piston of area A1. On the other side, the piston of large area A2 is attached to a platform where heavy load may be placed. The pressure on the smaller piston is transmitted to the larger piston through the liquid filled in between the two pistons. Since the pressure is same on both sides, we have the pressure on the smaller piston P is equal to force upon area, that is equal to F upon A. Then we can say that according to Pascal's law, the same pressure is transmitted to the larger cylinder of area A2. Hence the force acting on the larger piston, that is F2 is equal to pressure into area, that is F upon A1 into A2, that is equation 2. It is clear from equation 2 that force F2 is greater than F1 by an amount equal to the ratio A2 by A1. This is the principle we are using in hydraulic lift. The same principle we are using in different purpose, that is it is used in hydraulic press, hydraulic balance, hydraulic jack, hydraulic brake. They are all we are using this application of Pascal's law. Here we will discuss about hydraulic brakes also. See the hydraulic brake. It consists of a master cylinder fitted with a piston. The piston P is attached to a brake pedal with the help of lever system. The master cylinder is connected to the wheel cylinder through a tube. Wheel cylinder consists of two pistons P1 and P2. These pistons press against the brake shoes S1 and S2 as shown in this figure. Working. When the brake pedal is pressed with the foot, the lever system works. Piston P is pushed into the master cylinder. The pressure so produced is transmitted equally to the pistons P1 and P2 of the wheel cylinder. Due to this pressure, the piston P1 and P2 move outwardly and forces the brake shoes to expand outwardly. These brake shoes press against the inner rim of the wheel and retard the motion of the wheel. The master cylinder is connected to all the wheels of the vehicle in order to apply equal pressure to all the wheels. This is the working of a hydraulic brake.